The Yukon Government published both its new agriculture policy and its strategy for climate change, energy and a green economy in 2020. One element of these is to reduce reliance on food shipped into the territory by increasing the amount produced locally. For that to happen, forest has to be cleared. The Agriculture Branch obtained funding through the Canadian Agricultural Partnership to trial different methods of forest clearance and assess both the time taken to convert forest to land suitable for cultivation and the greenhouse gas emissions from each method.
In Yukon, the conventionally accepted method of clearing forests such as this to create agricultural farmland is during winter when the ground is frozen to take a bulldozer and press all these trees over, hopefully leaving the topsoil in the ground because it's frozen, popping out the roots. You will then push the trees together in piles or windrows, allow them to dry and set fire to them. The two alternative methods that we're experimenting with here are, instead of taking the woodland and destroying it as a waste, actually trying to utilize it to improve soil quality. So the methods are to take the woods, bulldoze them, pile them up, but chip them. And the next season when you sow in the field, cover the surface with wood chip as a mulch. That's called the surface mulch treatment. The other treatment is to take a forestry mulcher from the word go and take these trees and basically just mulch them into quite large chips. And then following that, take a subsoiler which then goes into the soil, takes all that wood and chips it into very small shreds and mixes it with the soil.
The effect of these two methods on the soil is very different, as Jonathan now explains.
Adjacent to the research plots, we needed a working area for the farm equipment. So this area was mulched. The forest was simply mulched, which means that it was turned into this rather coarse texture, which is left on the surface. And some topsoil mixed in, but the mulch does not go deep into the soil. Consequently, the root system is left, and generally there is bark left on some of the wood. And this results in regrowth within a few weeks of the mulcher being here. However, when you take the mulch plot and put a subsoiler into it, you get a totally different texture because it takes the wood and it churns it all up with the soil and you get a much finer, nicer texture. Now there is still wood in this, there's still plenty of wood in this, but the action of the subsoiler has actually stripped off the cambium or the bark layer, the growing layer, and you don't get any regrowth and you end up with a field.
One key element of this research is data collection. The greenhouse gas emissions produced during the clearance methods were calculated from the fuel use and the volume of wood burnt. Crop yields were measured after each year of growth, and costs were tracked throughout the project. Soil samples were collected from the plots prior to clearance and again during each year of the study. Samples were analysed for nitrogen, pH, organic matter content and soil microbiology. Here, Jonathan explains the soil structure that is present across not only the research plots, but much of this part of Yukon.
So at the top we have the organic matter lying over the dark, lying over a little bit of topsoil, and we have an ash layer, and then we're into the sand and the clay all the way down to the bottom.
The mulch and subsoil method was used to clear 3 plots from the research site in late summer 2020. The total machine and operator time was just 36 hours. The clearance happened too late in the season to grow a full crop, but in order to show how effective this method is, a small area was seeded with oats.
I'm standing on one of the subsoil research plots that was forest, but over the course of 2 days was mulched, and then the mulch was incorporated using the subsoiler to create a field. We then broadcast oats across a small portion of this as a demonstration, and within 3 weeks, as you can see, we have germination, we have oats growing. Normally, conventionally, this would happen within a year of clearing the forest, not within 3 weeks.
The 3 clearance methods were completed between 2020 and 2021. Multiple plots were cleared across the research site. The first full crop was sown in spring of 2021, following clearance. Crops were then sown each spring and data collected of crop yield and soil conditions. Jonathan and I met up in late 2024 to discuss the results. So maybe you could just explain why this project started in the first place.
Because when I started an agriculture branch back in 2018, around September, farmers, as was usual, or as usual, had dried windrows from cleared fields and cleared lands over the summer and set fire to them, to burn them, to get rid of the wood as a waste product. That created pollution and smog, which, not unsurprisingly, upset neighbours. Sometimes it would drag on for 7 to 10 days at a time if the wood wasn't dried very well. So I started to dig into why this process occurs and that type of land clearing. It's a conventional form of land clearing, slash and burn, pretty normal. But then you look into it and you say, okay, this is pollution, and what's the greenhouse gas releases, and perhaps there's another way to develop land rather than simply burning off the unwanted resources.
Okay. So where are we at now?
So we've had 3 years of measurable harvests. So we work those out as a yield in tonnes per hectare. And I'd like to start with the yield because incorporating wood into soil does run the risk of the microbes in the soil starting to digest that wood, and in so doing using up all the nitrogen in the soil and leaving nothing for the crop. And so in the first year you'd find out that the conventional procedure, which hadn't incorporated any wood, had a better yield. Probably about a 70% better yield. Ooh, looks good. In the second year, that was repeated. The wood incorporation yields increased, but so did the conventional, because the soil's being worked for 2 years now. The first year's harvest, which was more significantly higher than the conventional, was ploughed back in, so it provided organic matter as well, more than you would from the wood, although you have the wood in there, but remember the wood's being digested, and that's what's using up the nitrogen.
Yeah.
So by the fourth harvest, which was the third measurable harvest, we find the situation's flipped. We find that the wood incorporation treatments have got 30 to 40% higher yield tonnes per hectare than the conventional.
And what is it that's driving that in the soil?
As we look at the soil, we notice that in the early years, the original forest soil, in fact, contained no nitrogen, not detectable levels of nitrogen,
Right.
which is normal for the Yukon. So in the first couple of years, or the first season, spring and fall sampling of the conventional, and in fact all the plots, there was no spare nitrogen around. Then we started to notice, I think it was in fall 2021, the conventional plots start to build up some nitrogen, small levels, but it's there, and that is obviously supports why they have a better yield. And it took until spring 2023 for us to actually be able to record nitrogen in the soil on the surface mulch plots, and then the fall of that year, 2023, for the nitrogen to be recorded in the soil of the forestry mulch, which means now that wood's been digested to the extent that the microbes can do quickly, and it's gone into the very slow phase now, which means they're not eating all the nitrogen that we put in as a fertilizer. And that has simultaneously been, not coincidental, but as a result, we see the yield starting to change. So now, with that significantly higher yield in the wood incorporated treatments, we can say, okay, it's not just the nitrogen, because the nitrogen is not limiting anymore, it's there. So therefore, what the wood put back in the soil appears to be helping the plants provide a better yield. And 2025, I think, will be what I'd call a crunch year. Are these repeatable?
Okay, so that the wood that's been incorporated back into the soil, what I'm hearing is in the short term you don't really see a benefit, but over time it's a kind of almost like a slow release to give you those greater yields in years 3 and 4 or 2 and 3. I can't remember exactly, but basically to give you the greater yields as you go forward. And you think that next year you'll see that shift even more, yeah?
Yeah, so that was year 4. So we spent a normal sort of development would spend the first 2 years ploughing in the crop anyway to replace the, in a conventional sense, the organic matter that was burnt off. So here we've got turned back in crop and the wood, and there was a crystallisbista did some work which postulated that in our cold and dry climate the microbes would go gung-ho in the soil straight away on that wood, and they'd digest the most easily digestible stuff, and that would really suck the nitrogen. But then you get to the less digestible wood and everything slows down, which means they're not chewing on the nitrogen as fast, which means it's available for the crops. Down south or in warmer and wetter climates, they just keep chewing the nitrogen, so there is this continual lockup until all the wood's gone, which takes many years.
Okay. So you've got a reasonable understanding of the mechanism now of why things are happening. What about costs in terms of the development? I mean, how different was it between the different treatments in terms of the cost to actually do it?
Well, in the costs, between 2020 and 2023, which is when we developed from the forest and sort of got to the yield stage. The chipping was exorbitantly expensive. It had so many different phases, and each phase required a set of equipment and different pieces of equipment. And then we see that the actual cost, and it's just a figure, but the figure we got for the conventional was $8,700 a hectare. That involves all the rental of equipment, use of contractors. For the forestry mulch, it was $11,300. And the interesting point there is, yes, it's more expensive. It's $2,500 more expensive a hectare. However, that forestry mulch includes a subsoiling phase, and the subsoiling phase costs $2,500 a hectare. So we also found out that when we're subsoiling, we went 12 inches into the soil, which put a lot of the wood below the root zone.
Right.
It also caused a lot of fluffiness, if you like, put a lot of air into the soil, and it's very difficult to work for the first year. We think that caused a very poor soil seed contact, so germination was poor. So not only did the forestry mulch not have any nitrogen, it had poor seed soil contact, which meant for poor germination. So what germinated, which was reduced, actually didn't have much fertilizer anyway. So what we've actually done, actually, to carry on with this, is to take another plot of land elsewhere, another forest, and we just used the mulcher. And so we saved that $2,500 a hectare. We used the mulcher, and we went 3 inches into the soil just because in the Yukon, a lot of the roots don't have a major taproot from the trees. They spread laterally, and you can catch them with the mulcher going 3 inches into soil. And we're running a project now growing crops in that much heavily wooded layer compared to 12 inches. Okay,
and the same is true of the crops that you're growing, that actually the roots don't go that deep. So so what you're finding is that there's no real benefit from that deep subsoiling, from mixing that shredded woody material down deep. So there was an additional cost in doing that, but there was also no real additional benefit.
Yeah, we can't identify a benefit because sort of supporting that is the fact that the surface mulch is very expensive, but we put the wood on the surface, and then it was disked in, and disking in takes it to like the depth of the root depth into the root zone. And again, its yield in 2024 was similar to forestry mulch.
Okay.
So it's not a disadvantage to keep that soil near the surface, as far as we can tell.
Okay, so what I'm hearing is of the 3 treatments, so the conventional, the chip and spread, and the chip and incorporate, The conventional and the chip and spread very similar in terms of cost. More expensive to incorporate it, which I guess makes sense.
I'm afraid you're the wrong way around.
Ah, okay.
So the cheapest is the conventional.
Yeah.
The second cheapest is the forestry mulch, which is the incorporation
Yeah.
and subsoiling. And if you take the subsoiling section out, they're similar in cost. So you're mulching it into the top of the soil.
Okay.
And it's the extra steps to actually move that wood off the plot, chip it, pile it, and put it back on over 3 years. That pushes that cost up higher.
Okay.
But that showed us that you are putting this wood on the surface and just disking it into the top few inches. And now, after 4 years, that has created a much better yield than the conventional, and a similar yield to churning it in down to 12 inches.
Okay. All right. Yeah. I mean, is that what you were expecting to find?
We weren't sure what we were going to find.
I mean, I know that's the whole point of doing the research. But
So, well, we were hoping to find that there was an alternative that was cost effective and that didn't involve pollution and releasing unnecessary release of greenhouse gases, which we could come on to now.
yeah. That was going to be my next question, actually. Yeah.
So obviously burning wood, you're releasing greenhouse gases, depending on which piece of literature you look at. For every ton of wood you burn, you're going to release 1.2 to 2 tons of greenhouse gas. So we did our calculations, and we calculated the diesel use of the machinery, and you find that actually the subsoil really ate diesel. So it used that process, subsoiling, forestry mulching, used 3.8 ton, or released 3.8 tons of greenhouse gas from the fuel use per hectare.
And that's as equivalent to CO2, is it?
Yeah.
Okay.
And then the surface mulch, which is all the chipping and putting it back on, released 3.6 tons per hectare, so that's sort of similar. And then the machinery and the wood burning for the conventional released 326 tons, which is 88 times more or less the other two treatments.
And the big difference there is what?
That's the burning, that's the wood. So you're just burning off the resource, and it's being turned to carbon dioxide and ash. And the ash is like a 012 or 14 fertilizer, NPK, and it goes, we're short of nitrogen. So producing a fertilizer that has zero nitrogen isn't much use in our soils.
So okay, yeah. So, but what about one of the arguments that I know we've talked about in the past, that yeah, all right, so you're burning it and the CO2 is going up into the atmosphere when you burn it, but of course by chopping it down and mixing it into the soil, you're also losing all that CO2 eventually to the atmosphere. So why is that not incorporated into? Why is that not such a concern?
So we looked at it from the point of view that when you burn it over a period of in the case of a hectare, a few hours, 326 tons disappears up into the atmosphere,
Right.
It's in the atmosphere. When you sequester it, or you put it in the soil, it takes a lot longer to break down. Yet in those early 2 years, first year some of it's going to break down, some of that carbon will be released as greenhouse gases, some of it will be incorporated into the soil, and some of it's still there, not actually rotting away or changing in any way. It's just sitting there because of our dry climate. So what you're getting is a massive pulse of carbon dioxide. Remember, that's 1 hectare. We release 64 hectare lots. So when you clear a 64 hectare lot, that's an awful lot of carbon dioxide very quickly into the atmosphere.
When it's all burnt.
When it's all-
Okay.
Yeah. So it's just a time thing, and you can consider that in the Yukon it takes 100 to 150 years for a tree to reach maturity. So you're looking at, it might be called carbon neutral, but have we got 150 years? We're looking at sort of climate neutral things, which are on the order of 20 years.
Yeah. Okay. Yeah. Okay. And you talked about the cost of this in terms of the direct cost, but what if you actually look at the cost in terms of the carbon tax cost of burning the wood? Because I don't think that's incorporated into the government's calculations at the moment. But if you did, what would the impact of that be?
Yeah, that's right. The government doesn't include land clearing greenhouse gas costs or releases in its figures, and it also doesn't include them in rebate programs or offset programs. So in other words, there's no advantage to someone to say, I'm not going to burn, I'm going to mulch instead and give me the carbon rebate or tax rebate, or I can sell it or whatever. But when you use the April 2024 Canadian carbon tax figures, you find that the two wood incorporation treatments are quite similar. They're about $220 to $230 per hectare. and the conventional is $20,240
Got
per
it.
hectare, which means that if, which is hypothetically here, if the government would give carbon tax credits for land clearing, you wouldn't burn, because A, it's probably worth more than the carbon tax credit worth more than the land, and it's probably gives you twice the value of clearing by mulching.
Where next in terms of the project?
Well, fingers crossed, and hopefully everything goes well next year, and we repeat this year's yield results, and that's 5 years of yield results, and we'll be able to see that wood incorporation doesn't stop permanently, if you like, yields, and we will show that wood incorporation doesn't sort of permanently lock up nitrogen. You can use this system. And the second project that we're working on, which is just using the mulcher as a wood incorporation to the surface, that'll be into its second year next year. And as an aside, we're still stuck trying to get rid of the wood with bulldozers off because it didn't dry, so we couldn't burn it, and it's in a forest, so we don't want to burn it because there's danger of starting a forest fire, so we're trying to give it away and just, you know,
Right. Yeah.
we're going to have to chip that out because that's the responsible thing to do. And then we've got a mulch. So we'll be working on that for the next few years. Cut. Right, and then the other project which is running alongside this is that silver pasture is known as a carbon sequestration and a meat production technique to use the forest to produce meat and sequester carbon.
And what's the difference between that and other meat production?
Simply that you're using the forest in a more, managed and grazed manner than simply grazing or feedlotting, and you are actually using the cattle to regenerate or to improve the soil.
So you have the cattle actually almost in the forest.
In the forest, and they will start like mini bison, the mini bulldozers themselves,
Yeah.
and they'll start taking out and pushing down those trees. And we're going to incorporate what we've been doing with a project we call Cattle in the Forest, to show that cattle can be used as a pre-clearing treatment or as a silver pasture development treatment from existing forest. We did have to put in a mulcher on that project, just as an aside, a mini mulcher to run around for 3 days and clear up all the fallen trees that they'd knocked down because they were becoming dangerous and entanglement for the cattle. And the interesting thing is we calculated its diesel use, which released as much greenhouse gas as if in that 16 hectare area we'd burnt the wood from 27 square metres of the forest.
Of course, so quite a considerable difference then.
Yeah, huge difference. You do have to use machinery sometimes, fine, but at the same time we took meat off that for 2 years, that plot for 2 years, while we were creating the silver pasture.
Interesting. Okay. Well, good luck for the future.
Well, thank you very much.
Okay.